We are in Unit 10. This is day 3. We are doing motion along a curve today with a calculator to help us. Okay, so let's dive in again with some examples. In this first example, we have a particle in the xy plane where they give us the x coordinate and the y coordinate, and they give us a time restriction. Time is between 0 and 2 pi. And they just ask us, what distance does the particle travel? What distance does the particle travel between the two x-intercepts? Well, let's focus on this first. The distance the particle travels. That is our integral from time A to time B, square root x prime squared plus y prime squared. Hopefully after doing your homework that is in your head now. Okay, so square root x prime squared plus y prime squared. Distance, that's our distance formula. So we need the two times. So we need the times where the particle is hitting the x-axis, right? Well, the particle hits the x-axis, I might even write that down. The particle is at the x-axis when y is 0, right? That's when we're at the x-axis. So we want to set y equal to 0. And we could do this on the calculator, but I'm looking at it and it looks awfully easy to use our unit circle values. I'm thinking that you'd probably use your calculator for this, but I'm going to do it both ways. Here I would get sine t is equal to positive 1/2, so t has to be either pi over 6 or 5 pi over 6. That's not that bad. However, if you did do it on the calculator, I would go to my y equals screen. I'd put 1 minus, you know what I might do? Yeah, well, I'll do that. 1 minus 2 sine t okay, and then for my window, I only need to see from 0. Well, I need to see from 0 to 2 pi. I've got some messed up window here, so I'm going to fix that real quick. I'm just going to go from negative 2 to 2 because I know this is just okay. Something is off here. I know exactly what's off here. I've been working with my pre-calc kiddos. That wasn't going to do me any good. Okay, so I had to put it in radian mode. Okay, so I'm going to go ahead and put 0 in for my y-axis. So I have second calc 5. Come over here a little bit. Enter, enter, enter. So that's 0.5235988. So you could write that down. 0.5235988 ... And remember, you have to write at least 3 decimal places, right? And come over here a little bit, get this 5 pi over 6 one. 2.61799939 ... Okay, so you have to write at least 3 decimal places. Okay, and we could store that in for B. We could store this one in for A. I didn't do that, but we could definitely do that. The current x value, store that in for B. There's that same number. And the current, the other x value that we had, that should be my pi over 6. So instead of going back and finding that one, and it is indeed, you can see it is pi over 6. I'm just going to store that in for my A. Okay. All right. So now I have my times. I have my 2 times what that the particle is on the x-axis. So the distance will be the integral from A to B of, okay, I need x prime. What is x prime here? All right, x prime is going to be, it's going to be positive 4 sine t. And we square it because that's in the formula. Plus, now I need y prime. Y prime is going to be negative 2 cosine t. Okay? And that is equal to, okay, integral A to B square root parentheses, make sure you get all this in correctly. I don't have to put a negative in there, but I'm going to just have it match exactly. And we get 7.347. Okay? So that's the distance the particle traveled between the 2 x-intercepts. Okay, number 2. And in number 2, this is a multi-part problem. In fact, on the next page it continues. So there are 5 parts to this problem. Since there are 5 parts to this problem, it's like an FRQ. Okay, in an FRQ on these types of problems, put x prime of t in for y1 and y prime of t in for y2. That's a general advice for you. Okay, do that whenever possible. Okay, so we'll see if it's possible here, but that's in general multi-part motion problem. Put the derivative, put velocity into your calculator. Okay. All right, and in here I'm reading along, and they do indeed give us dx dt and they give us dy dt. So I'm going to do that. I'm going to come back, and for y1 I'm putting sine of t cubed, and for y2 cosine of t squared. Okay, so I have those 2 in. And then they give me this information. At time 2, the particle is at 7, 4. That means x at 2 is 7, y at 2 is 4. If they give me an initial point, I can find any other point using the fundamental theorem, as long as I have a point and the derivative, which I do here. Okay, part A. Write the equation of the line tangent to the curve at the point when t is 2. We can do this. I need a point and a slope. So the point is at time 2 is the exact thing that they gave us. So the point is going to be 7, 4. The slope, dy dx, at time 2 is dy dt over dx dt at time 2. So dy dt, and you know what? I have the calculator. I'm just going to let my calculator do this. I could just plug it in. It wouldn't be that hard, actually. My goodness. It would be really easy just to do it like this. Cosine of 4 divided by sine of 8. That was way easier than typing it in my calculator, right? So I think I'm just going to leave it like that. It's an FRQ, leave it like that. If we wanted to, we could get a decimal value for that, but there's no reason to. So the equation of the line tangent would be y minus the y value is the slope times x minus the x value. Perfect. Not a problem. Okay. You guys, when you're writing the equation of the line tangent, you should have an x and a y and no other letters involved. One x, one y, no other letters. For some reason, I always get some kids who want to put in t's and stuff. There shouldn't be any t's left. You should have used the time that they gave you to get all of that out of the way. All right. Find the speed of the particle at time 2. So we need to pull out of our pocket our formula for speed. Speed is square root x prime squared plus y prime squared. Know your formulas. Okay? So the speed at time 2 is going to be the square root of x prime at 2 squared plus y prime at 2 squared. Okay? I think I will just use my calculator now. I have x prime stored in for y1 and y prime stored in for y2. So I'm going to go to my home screen. Square root x prime is my y1 at time 2. Remember, your calculator can use that notation. That is going to evaluate y1 at time 2. And I'm going to square that plus y2 at time 2 squared. So you can type it in exactly like you have it in your on your paper, if you remember where you put your x prime and your y prime, which shouldn't be hard if you do the same thing every time. So two answers would be accepted here, 1.185 and 1.186 if you round that. Alrighty. On the next page, for what value of t between 0 and 1 does the tangent line to the curve have a slope of 4? Okay. And then we're supposed to find the acceleration vector at that time. Lots going on here. First of all, we're going to answer the first question. At what value of time, for what value of t, is the slope 4? Well, the slope is dy dt over dx dt. We start with that, which is y prime of t over x prime of t. Either way you want to write that is fine. Either one. You don't have to do it both like I did, but either one is good. We want that to be 4. Let's go to our calculator. Okay, I have that stored in for, I have y prime in for y2 and x prime in for y1, correct? So I can make y3 y2 divided by y1. And now that's my slope. I can turn this one off. I can turn that one off so I don't see it. I don't want to see everything. I only want to see the slope, and I want to see 4. Right? And for my window, I only need time between 0 and 1. So I'm going to restrict that to 0 to 1. For my y min and y max, I need to make sure it includes 4, so I think I'm going to go up to 6. There's the slope. There's y is equal to 4. They intersect at t is equal to, I can't even see that, it's a little pink thing. I'm going to come off to my home screen and pull that up again. Oops. 0.616 dot dot dot. I'm going to store that in for A so I don't lose it. Alright? Because now I want to find the acceleration vector at that time. So acceleration vector at that time is going to be the second derivative of x at that time. I don't know why I'm using, I don't want to keep writing that down if I can just put what I said that I stored that in, y double prime at that time. And now I'll come and do it. So my home screen, I need x double prime at 8, so I need the derivative of my y1 at that value of time, right? So math 8 is my derivative of y1 at time a. And now I'm going to come do the same thing, except instead of y1, put y2. And that's it. Okay? That would get you full credit. All right, part D. Find the position of the particle at time 1. Position. So I need x and y at time 1, right? So fundamental theorem. They gave us, remember they gave us the position at time 2. We want the position at time 1. So I'm going to set up fundamental theorem. X of 2 minus x of 1 is the integral 1 to 2 of x prime. Okay? Which means that I'm looking for x of 1. I was given x of 2 is 7. Okay? And so x of 1, do a little math here, do a little algebra, is going to be 7 minus that integral. And we can let our calculator do the actual integrating for us. So 7 minus math 9, 1 to 2 of our y1 is 6.781 or 6.782. Either one is acceptable. Okay? Same thing for our y's. Y at 2 minus y of 1 is the integrals 1 to 2 of y prime dt. So y of 1, I'm going to save myself a step, is, so our y of 2 value is 4 minus that integral. And let our calculator do the work for us. So we have 4 minus integral 1 to 2 of our y2. 4.443 is the only one that they would accept there. So the position at time 1 is, and they gave me the position, I'm looking back at the original problem, they gave me the position used in parentheses, so I'm just going to use parentheses. And I just chose that first x coordinate that I found. So yeah, that's the position. And now in part E, find the magnitude of the displacement. Remember, magnitude of the displacement was that one that we found where we're looking for the length of a slanted line where the x component is just change in x, the y component is just change in y. So this will just be change in x squared plus change in y squared. So the magnitude of the displacement will be the square root of change in x, so x of 2 minus x of 1, minus y of 2 minus y of 1, both of these squared. Alrighty? So, let's see. we found, we were given the x of 2, we were given these. So x of 2 we were given is 7, and we just found x of 1. Oops, plus in here, goodness, plus. Y of 2 we were given is 4, and y of 1 we just found. So even though I'm writing it with 3 decimal places, I need to use the entire value to make sure that my final answer is correct to 3 decimal places, right? So I'm going to have square root, parentheses, 7 minus, I'm going to go up and get the 7, that whole value, close parentheses and square, plus, parentheses, 4 minus, go up and get this 4.443 number, close parentheses and square, and we get 0.493, or acceptable is 0.494 to round that final answer. And that is one whole problem using a calculator on this material. And that's it.